Our 2021 senior design project is core shell 3D printing. Team members are Seth Anderson, Kahl, Jacen Wentzell, Brock Olafin. Mentors are Dr. Jiang and Damian Mohawk. This project was funded and sponsored by NDSU's Mechanical Engineering Department. Core shell 3D printing involves printing two materials simultaneously. This can improve physical characteristics such as strength or weight over a homogeneous material. The graphic on the right shows a cross-section of a core shell 3D printed filament. The outer green shell is typically a hard plastic, and the red core can be a variety of materials, such as a different type of plastic, a fluid, or even a hollow space. Hollow shell filament can also have applications such as insulation, material reduction, or even as tubing to carry fluid through the print. The goals of our project is to develop a core shell 3D printing attachment that will work with any off-the-shelf 3D printer. Our printer was donated by Lulzbot, and it's a TAS6, and it's a commonly available printer that can be found at any 3D printer supply shop. Next, we hope to explore the different material combinations that could be possible and the variety of physical characteristics that they might give to our parts. Our third objective is to test the feasibility of 3D printing with these different combinations of materials. The design we came up with includes 6 major parts: the resin needle, the heater block, printer nozzle, filament channel, heater cartridge, and heat break. Thermal analysis was then conducted on the assembly to determine the max temperature of each component. After the design was finalized, the interior features were then manufactured on a standard 3-axis CNC mill. Stock components such as the heater block were then modified by probing and drilling attachment holes so that it can bolt to the bottom of our mixing chamber. Once all of the components were manufactured and assembled, simple function testing of the system could begin. A majority of our materials testing involved a PLA outer shell and an oil-based inner core. In this picture, you can see a cross-section view of the filament that was created. Once the filament is cut open, it leaves a hollow inner core as the oil leaks out. Once the best settings were determined through testing, we attempted printing more complicated structures. In this video, you can see our machine printing a simple rectangular structure. The results of these tests conclude that we can print simple structures with multiple materials, but layer adhesion is poor due to the oil permeating through the plastic. Further testing with different materials may provide better properties.